Next rule we have to look at is the quotient rule, and this is probably the rule that you will be using the most, because this is when you would have, say, something that looks like this. You have like 2x minus 3 over, let's say, I don't know, x squared minus 4x plus 20. Something like that, where you have a rational, is when you're going to most likely use the quotient rule. And here's the rule, and it is very disgusting looking, but here's how we're going to read this, okay? This is going to be, I'm going to read this as low, because it's the one that was on the bottom, times the derivative of the top. I'm going to say d high. So low times d high, low d high, minus, I have the upper function, the high function. This is the derivative of the bottom function. So low d high minus high d low, and that's all over low squared. So that's how I would remember this. Low d high minus high d low all over low squared, you know. That's how I'd remember our quotient rule. So let's, again, get right into some examples of how we're going to use this. Again, there's your function, or I'm sorry, there's your rule to look at. Something that I should look for right away, though, especially if I only have one term on the bottom, is I can kind of simplify this even and not even have to worry about quotient rule. I can simplify this guy. This is like x to the first power, and this is like x to the 1/2 power. So if I have 1 minus 1/2 to simplify that, that's the same as saying 5x to the 1/2 power. And same here, I have this would be like x to the 0th power, 0 minus 1/2 would give me x to the negative 1/2. So I don't even need to use quotient rule if I didn't want to for this one. I could just go and take the derivative now, and when I do that, I would get f prime of x would equal, it would be 5/2 x to the negative 1/2, and then when I bring this guy down in front, it would be 1/2 x to the negative 3/2. So I don't even need to use quotient rule for that problem at all. Now if I wanted to use it, just so you can see what it would look like, it would be f prime of x would be low times d high, the derivative of the top would be just 5, minus high d low. So 5x minus 1 times derivative of the bottom would be, it would be x to the 1/2, so it would be 1/2 x to the negative 1/2, all over low squared. Low square root of x squared is just x. And I could simplify this down just so you can see, if you wanted to, you could try to simplify anything that you could, and you would end up with this same answer, but in the end, either way looks just fine. So again, this looks a lot neater and it's a lot easier to do than that if you're able to. And this is much more likely what you would find for an answer when you get to a multiple choice question. All right, let's look at this one here. Nothing I can simplify here, so let's just go right into this quotient rule. So g prime of x here is going to be low d high, so x squared plus 1 times derivative of the top is just 5, minus high d low. 5x minus 2 is high, d low would be 2x, all over low squared. X squared plus 1, that whole thing squared. I would leave this in that factored form as long as you can, because you'll see down the road we have very often things will end up canceling out. Let's try to simplify this. I'll have a 5x squared plus 5. I'll have a minus, when I distribute these through, I'll have a minus 10x squared, and then this will be minus 4x, but that negative will make it a plus 4x, all over, same thing, x squared plus 1, the quantity squared. And then last thing, just to try to simplify it more, I'll have a negative 5x squared, I have a plus 4x, I have a plus 5, all over x squared plus 1, the quantity squared. Again, on your answer sheet on a AP test, this bottom might be expanded. If so, I think it's easier to see it expanded than to see it back contracted in. So I think that's the easier and safer way to go. All right, this next one, for h prime of x, it's going to be low d high. There's your low. Derivative of the top is negative sine of x, minus high d low. So the high is cosine x. The bottom is d low, that is 2x plus 3, all over low squared. So x squared plus 3x, that whole thing squared. Now I'm not going to be able to simplify this much, but definitely want to try to at least get the sine and cosine undistributed there. So this will be negative x squared sine of x for the first start. Now I'm going to have a minus 3x sine of x. Then I'm going to have a minus 2x cosine x. And I'll also have a minus 3 cosine of x. And again, all this is still over x squared plus 3x the quantity squared. And that's probably about as far as you're going to be able to simplify this. A lot of people ask, how do I know when I'm done simplifying? There really is no way to know for sure. In general, you want to get rid of parentheses, get rid of negatives. It's about the best you can do in the end. All right, now this last one doesn't look like quotient rule here. However, maybe you remember back from your trig days, tangent is the same as saying sine divided by cosine. So knowing that, let's see if maybe we can take a little quotient rule here. Let's go, so y prime would be, okay, low d high. So the low is cosine of x. The derivative of the top is also cosine of x. Minus high d low. The high is sine of x. The low is, or d low is going to be derivative of cosine, which is negative sine, all over low squared. Well, this is how you write cosine of x squared, is just cosine squared of x. Okay, when I simplify this top, I'll have cosine squared x minus, well, negative and negative makes it actually a positive, sine squared x, all over cosine squared of x. One of our trig identities, sine squared plus a cosine squared is always 1. So we have 1 up top, cosine squared on the bottom. Well, guess what? Cosine squared, or I'm sorry, 1 over cosine. Well, let me even write it this way. 1 over cosine times 1 over cosine. 1 over cosine, we said, was the same as secant. So this answer is actually secant squared of x. And what you just did is you actually just proved what the derivative of tangent is. So it's going to be good for you to remember that the derivative of tangent is always secant squared. But at the very least, if you ever forget what the derivative of tangent is, you should always be able to go back and figure it out using the quotient rule.